Today we're going to talk about scientific notation. Scientific notation is going to be very important for this course because we're going to be dealing with a lot of very large numbers and a lot of very small numbers. And instead of writing out all of these numbers, we can simplify it by putting it into scientific notation so the number is still the same, but we are just not taking the time to write out the complete number. So in order to understand scientific notation, we have to be able to distinguish the difference between a standard notation and scientific notation. Standard notation is what you have typically seen. So for example, 0.003 would be an example of something in standard notation. Another example of something in standard notation would be 3497. Okay, both of these are examples of numbers that are in standard notation. They're the way that you have been taught to write numbers all along. What we want to do is we want to convert these into scientific notation. There's a very specific format for the way that we complete scientific notation. The first thing is that scientific notation can only have a ones place. Okay? And then it could have as many decimal places as necessary. So we have a ones place and then necessary decimal places. And then at the end of it, we have a times 10 raised to some power. And we're going to learn how to figure out what that power is. So let's look at these for example. What we want to do is we know that we can only have a ones place. So that means that our 3 has to be our ones place. In order to do that, we have to move our decimal place over so that our 3 is the only non-zero number in front of that decimal place. So now we have our decimal place right there. Now if we think about it, we moved this decimal place over 3 times. 1, 2, 3. Now because this number is less than 1, our exponent is going to be a negative. And since we moved it over 3 times, it's a negative 3. So here we have 3 decimal. We don't really need this decimal here since we're not putting any numbers to the right of it, times 10 to the negative 3. Okay, let's look at this example. Here we don't see a decimal place, so we can pretend that there is a decimal place at the end of the number. Okay, now we know that we can only have a ones place, so again, the 3 is going to be the only number that is in our ones place. So let's move our decimal so that our 3 is the only number in our ones place. So we'd have 3.497. We can't just get rid of these numbers because they're not a zero, so they do matter right now. So we have 3.497, and again we need a times 10, and we have to figure out what that exponent is. Because the number in standard notation is bigger than 1, we can say that the exponent has to be positive. And we move the decimal place 1, 2, 3 spots, so now it's a positive 3. Okay? Now we're going to be doing this for numbers that have any more than 4 spots will be required to be in scientific notation. Anything less than 4 spots can be in standard notation or scientific notation unless it's specifically asked for one or the other in a problem. Okay, so let's just look at a few more example problems to make sure we have the hang of this. All right. So here, we can only have one number in the ones place. So that's going to be 1, 2, 3, 4, 5 spots so that we have a number in the ones place. So that's going to be changed into 5.67. And this number is less than 1. So it means that we have a times 10 to the negative exponent and move it over 1, 2, 3, 4, 5 spots. So times 10 to the negative fifth. Here, our decimal place needs to be between the 4 and the 9, so we only have one number in the ones place. So again, we're going to pretend that the decimal was originally at the end of it, and we have to move it over 1, 2, 3, 4, 5, 6, 7 spots. So it's 4.97 times 10 to the positive 7, since this number was originally greater than 1. Now let's go in the other direction. We have 9.23 times 10 to the 6th. This number is positive, so that means that the original number in standard notation had to be greater than 1, which means that we have to move this decimal place over to the right to make it a larger number. So what we want to do is we have 923. Our decimal place was originally here. So 1, 2, 3, 4, 5, 6. And fill in the missing spots with zeros. Now for this last one, we have 7.1 times 10 to the negative fourth. This number is negative, which tells us our original number was less than 1. So we have to be moving our decimal place to the left to make it a small number. So we're going to have 7, 1. Our decimal place was originally here. Now we have to move it over 4 spots. So 1, 2, 3, 4. That's where our decimal place will go. And fill in the empty spots with zeros. Okay? Now the last thing that I want to show you is going to be scientific notation on your calculator. A lot of you have calculators that look like this. And what you want to do is make sure that you recognize your scientific notation. A lot of the time, scientific notation is going to show up in your calculator with an E. So let me show you that E. Okay, it's going to be a capital E. The E stands for times 10. The number that comes after the E is your exponent.